So today we will be drawing dipole arrows and partial charges. So to draw these dipole arrows, we have to have the arrow start at the less electronegative element, which has a partially positive charge, and then point towards the more electronegative element, which has a partially negative charge. And this arrow is signifying the movement of an electron from that less electronegative element to the more electronegative element, as the more electronegative element has a stronger pull on that electron. So how do we know which element is more electronegative? Well, in the bottom right-hand corner of each little square on your periodic table, there's a little number that tells you exactly what the electronegativity is. And the higher the number, the greater the electronegativity is. And so with our example here, chlorine with an electronegativity of 3.0 is more electronegative than hydrogen, which has an electronegativity of 2.1. So when we are doing this, we have to give the more electronegative element a delta negative sign. Excuse me. Delta negative. And the partially positive one, the little delta positive. And so the way I remember the arrow, even though we know it's signifying the little pointing thing, a few tricks don't hurt, I always remember that the partially positive one has that little plus on the arrow. And if you look at it closely, you can kind of see how it can be a little plus sign there. And since there's not that little plus thing on the other end, you can almost think of it as a little negative sign. So the more electronegative one has the negative sign. And so putting this into practice, if we are trying to see if something has a nonpolar or polar covalent bond, we have to see what the difference in electronegativities is. And the way we can see this is if something has an electronegativity difference of 0.4 or less, it is going to be a nonpolar bond. And if it's greater than that, it's going to be a polar bond. So between carbon and hydrogen, carbon has an electronegativity of 2.5. and hydrogen has an electronegativity of 2.1. So the difference between these, you just subtract them, is 0.4, which is included in nonpolar covalent bonds, which means this will be nonpolar covalent. And then when you're modeling this, you draw out the bond. And since it's a nonpolar covalent bond, we don't add any of these dipole arrows or delta positives and negatives because those are signifying the movement of an electron, which isn't present in a nonpolar covalent bond. So with carbon and oxygen, oxygen has an electronegativity of 3.5, and carbon has that electronegativity of 2.5. So the difference between these is 1.0, which is greater than 0.4, meaning that it is a polar covalent bond. And so, again, we just draw out the bond when we're modeling it, carbon to oxygen. But now we have to add the little dipole arrows and deltas. And so since oxygen is the more electronegative element, it's going to get the little negative dipole, and then carbon will have the little the negative delta and then the positive delta. And the arrow will point to the more electronegative oxygen with a little plus atop of carbon. Now our final example with nitrogen and hydrogen. Nitrogen has an electronegativity of 3.0, and hydrogen has an electronegativity of 2.1. When you subtract them, you get 0.9, which is greater than 0.4, meaning that it is also a polar covalent bond. And so then you draw the little bond, nitrogen, hydrogen, and nitrogen has the greater electronegativity and receives that delta negative, with hydrogen receiving that delta positive. And then the arrow will point to the more electronegative nitrogen with the plus sign on top of hydrogen.